Parallelizing sorting is going to be a lot like parallelizing hashing. We're going to shuffle the data across the network so that each machine can get data to sort on its own without further coordination with the other machines. The difference between this and hashing is that the way we're going to partition the data in this first pass is different. So of course in sorting we talk about pass 0 being the pass in which we read in blocks, we sort them in memory, and we write them to the disk. So we're going to change that here so that when we're reading values in from the disk, we figure out which machine to send that tuple to, and then that machine will put it into its buffer. So just for convenience in this example, we'll split the range of possible values across these three machines as follows. The lowest values will go to the first machine, -infinity to 10. Medium values, 11 to 100, will go to the second machine, and the highest values, 101 to infinity, will go to the third machine. So each machine will gather up B blocks worth of records from the inputs to generate a run, split according to these split values. And then the rest of sorting for that block is going to work just like it did locally. We're going to sort that thing in memory, we're going to write it to the disk, and then we're going to request another B blocks of data from the inputs. So the inputs are being scanned and partitioned across the machines according to these ranges, and then they're being sorted locally. And then the second, so what's called pass 1 in sorting, which is the second pass, is going to merge the local runs into large local runs on the disk. And when we're done, the data has the lowest values in order on the first machine, the medium values in order on the second, and the high values in order on the third. Essentially, the file is sorted and spread across the three machines. The wrinkle with sorting that we didn't have in hashing is it's pretty tricky to ensure that every machine gets the same amount of work. How do we ensure that these ranges that we picked, which in the example were pretty arbitrary, each have the same number of pages? If we don't do a job of this, we say that we've skewed the workload across the machines. We have too much data on one machine and not enough data on another. That's called data skew. So how do we avoid that? Well, the answer to that's a bit outside the scope of this lecture. But basically, you can think about doing this. If you knew the distribution of values and you knew which were popular values and which were less popular values, you might be able to figure out where those split keys go. So the challenge then is to quickly gather up an estimate of the distribution of values on your sort column to allow you to choose where those split points should be for sorting.